Hello, my name is Cole, and this is my presentation on 700 million gallons, Seattle's Green Stormwater Infrastructure Project. The evergreen forest system that covered most of the Puget Sound region managed rainfall in a way that slowed down water, allowed it to evaporate back into the air or soak into the ground, filtered the water through plants and layers of soil, and replenished the groundwater that feeds our salmon-bearing creeks. As Seattle developed into the booming city it is today, the forest system was replaced with large stretches of impervious surfaces such as roads, buildings, walkways, and parking areas. In order to deal with the runoff water, an underground pipe system was created, and the runoff was either routed directly back into our waterways or into combined sewage storm water pipes. This has created two problems. First, as our city has grown up, the volume carried by our combined sewer system has begun to reach maximum capacity, resulting in flooding events. Second, as water rushes over impervious surfaces, it picks up pollutants such as oil, grease, metals, and toxic chemicals. Much of this water is being routed directly back into our freshwater and marine waterways. The Puget Sound Partnership has identified this pollution from roads, roofs, parking lots, and other paved areas as the largest threat to the health of the Puget Sound. Low-impact development, or LID, is a stormwater and land use management strategy that strives to mimic pre-disturbance hydrologic processes of infiltration, filtration, storage, evaporation, and transpiration, by emphasizing conservation, use of on-site natural features, site planning, and distributed stormwater management practices that are integrated into a project design. Green Stormwater Infrastructure, or GSI, is Seattle's term for the low-impact development-based stormwater management practices. Seattle's GSI suite includes trees, bioretention, permeable pavements, green roofs, and rainwater harvesting. In addition to the stormwater management functions of these practices, these technologies can simultaneously help filter air pollutants, reduce energy demands, mitigate urban heat islands, and sequester carbon while also providing communities with aesthetic and natural resource benefits. Seattle was one of the first cities to require GSI as part of new developments, and from the success of this requirement, the Washington State Department of Ecology now requires the use of GSI statewide. New developments must adhere to the three LID principles of minimizing impervious surface, minimizing stormwater runoff, and preserving native vegetation. GSI serves more than just ecological functions. The aesthetic and health perks of GSI implementation has attracted and inspired community partnerships in a way that traditional piped infrastructure has been unable to. Finally, GSI processes are helping Seattle reach its 2050 climate neutrality target in several ways, such as reducing demand for pumping and water treatment. GSI is also a principal method of the Equity and Environment Initiative of 2015, which supports environmental progress, focuses on communities suffering from environmental injustice, and empowers minority and underrepresented communities. By 2025, the population in Seattle will grow to over 700,000. Seattle's goal is to divert 700 million gallons, which translate to 1,000 gallons per resident. This is a fraction of the 20 billion gallons of stormwater generated in Seattle each year. Each resident is therefore responsible for managing 1,000 gallons, which is approximately 70 square feet, and there are many different methods in order to do this. These tools have been developed in order to be applied on both public and private land. Seattle's green stormwater infrastructure has developed 8 different strategies in order to manage stormwater, ranging from planting trees to installing permeable pavement. These methods seek to not only restore ecological functions, but to also improve aesthetic qualities. This generates an economic incentive, as improving aesthetics improves the value of a house and the surrounding areas. This can result in gentrification and has raised issues in neighborhoods considering GSI because individuals worry they could be priced out. A healthy urban forest provides benefits including air and water pollution mitigation, habitat for wildlife, and stormwater runoff reduction. Trees and other plants improve air quality by intercepting particulate matter and absorbing pollutants. Trees serve several functions concerning stormwater runoff. First, they intercept rain and prevent a portion of it from reaching the ground. Second, when their leaves fall, they help build the soil up, which then retains moisture and effectively slows and cleans runoff. This process also recharges groundwater. Finally, tree roots absorb water and eventually release it back into the atmosphere through transpiration. Trees are also useful in reducing carbon in the atmosphere. In the 2013 Urban Forest Stewardship Plan, it was stated that urban forests in Seattle stored over 2 million metric tons of CO2. In the plan, it was also identified that trees increase property value and add aesthetic qualities that reduce stress. The case study of vegetated roof covers in Philadelphia, Pennsylvania, found that vegetated roofs help recreate hydrologic functions of open space. Vegetated roofs capture and hold precipitation in the plant foliage, absorb water in the root zone, slow the velocity of direct runoff by extending the flow path through the vegetation, and cool the temperature of the air and runoff, reducing the thermal shock of runoff from hot roof surfaces. Other benefits from vegetated roofs include insulation in the winter and cooling during the summer. Like planting trees, green roofs also decrease pollutants in the air and increase the value of a home. Amending soil with compost helps rain soak in and builds healthier landscapes. This approach reduces the need for irrigation, fertilizers, and pesticides. Mixing compost into the soil, mulching gardens with leaves or wood chips, and mulching lawns by leaving the clippings are the best and easiest methods to slow, soak in, and clean stormwater. According to the Rain Garden Handbook for Western Washington, a rain garden is a landscaped area that collects, absorbs, and filters stormwater runoff from rooftops, driveways, patios, and other hard surfaces that don't allow water to soak in. Rain gardens are sized to accommodate temporary ponding after it rains and are not meant to be permanent ponds. A rain garden is a shallow depression constructed with soil mixes that allow water to soak in rapidly, treat runoff, and support plant growth. Some problems have been identified with rain gardens as nutrients can leach from the soil and in the case of Redmond, can cause algae blooms in nearby rivers. The handbook calls for a 40% compost, 60% sand soil mixture, which, after sampling, results in 5 to 8% organic matter. This value is congruent with the 5 to 10% organic matter found in native Northwest forest soils. So the question we're left with is, what's better, human-caused nutrients or human-caused pollutants? A stormwater cistern is a large above-ground container that stores and allows the reuse of rain. The cistern attaches to the downspout from the roof and catches water runoff. They can hold several hundred gallons of roof runoff and slowly release it back into the ground. Cisterns are relatively easy to design, install, and maintain. According to the results of the field evaluation of permeable pavements for stormwater management in Olympia, Washington, permeable pavement systems dramatically reduced surface runoff volume and attenuated the peak discharge. They also found that while there were significant structural differences between the systems, the hydraulic benefits were consistent. This method can be costly and require professional installation, but it maintains a durable driving surface for cars and people. Depaving is the process of removing unnecessary pavement and replacing it with plants, trees, permeable pavers, or permeable asphalt. This process restores vegetation and opens up opportunities for other ecological functions. While the actual process of depaving is laborious, the results are fairly obvious. You remove the impervious surface, and you remove the cause of the problem. The Bioretention Applications case study of Inglewood Demonstration Project in Largo, Maryland, and the Florida Aquarium in Tampa, Florida, demonstrate the ability of bioretention as a viable method of pollutant removal. Bioretention is cost-effective compared to similar level pollutant removal methods and have the added benefit of decreased runoff volume, temperature, and increased aesthetics. The bioretention ponds are also very resilient in droughts as water is stored in the system. The bioretention system is like a rain garden, but larger and more complex. It handles the most stormwater relative to its size and is typically used as a public space or on a commercial property. A roadside raised garden is the form of bioretention and is useful in capturing and cleaning runoff from the road. This is a list of organizations that have been involved with building GSI in Seattle. Because of these organizations, community partners, philanthropies, private developers, Seattle Public Utilities, and King County Wastewater Treatment Division, nearly 100 million gallons of polluted runoff have already been managed by green stormwater infrastructure. This is a good start, but in order for GSI to grow, residents need to start taking advantage of the vast pool of resources supplied by government and non-government organizations. Residents in West Seattle were anxious to install dozens of roadside rain gardens. They had heard half-baked tales of sinkholes and mosquito infestations from the Ballard Rain Gardens. In order to appeal to the worried residents, the county held 24 public meetings on the streets where the swales would go, and using red wagons, they hopped from spot to spot, bringing with them life-size tarps to represent the rain gardens. Through public engagement efforts, the citizens were educated on what the installations would look like and their function. Over 150 people participated, and by the end of the house-by-house support building exercise, the citizens were excited for the new improvements. This is a list of sources that supply funding opportunities such as grants and rebates for homeowners, residents, and organizations in order to build GSI projects. These resources supply incentives for the adoption of GSI methods and demonstrate the desire the community and government have for the adoption of ecological improvements. Rainwise is a program that advocates GSI principles and provides a rebate for the installation of a rain garden or cistern in selected areas of Seattle. The Neighborhood Matching Fund gives matching dollars for neighborhood improvement, organization, or projects that are developed and implemented by community members. There are three different funds: the Small Sparks Fund, up to $1,000, the Small and Simple Projects Fund, up to $25,000, and the Large Projects Fund, up to $100,000. Of course, each level of funding has varying tiers of requirements. The Seattle Relief for Neighborhoods project has helped residents plant over 6,300 trees since 2009. Trees for Neighborhoods participants receive up to 4 free trees, a watering bag and mulch for each tree, training on proper planting and care, assistance applying for street tree planting, and ongoing care reminders and future pruning workshop opportunities. The Seattle Neighborhood Park and Street Fund can be used to fund up to $90,000 for park or street improvements. This includes traffic circles, speed humps, or potentially a rain garden. The project requires significant support from the community. The King Conservation District awards grants for projects that improve the condition of natural resources. The program is highly competitive and distributes $370,000 per year. Projects are rated by the number of natural resource improvement activities provided. In conclusion, urbanization has created environmental problems that affect both man and nature. The potential disastrous effects of stormwater runoff, whether it be flooding or the spread of pollutants, are problems that we can minimize. Through the use of GSI biomimicry technologies, we are capable of coming closer to nature. While we can't play the role of Mother Nature, we can attempt to pay tribute to her.